Hello students, welcome to 8th Standard Science, Term 1, Lesson 1, Measurement Part 2. In earlier session, we discussed about definition of measurement and some kind of measuring instruments, different kinds of fundamental quantities and their units, system of units and need of international system of units. In this session, we are going to discuss about remaining fundamental quantities. Before entering into the lesson, I just want to remind you that please maintain a separate notebook and note down all the important points which will help you to revise the topic again and again, and also it is helpful to answer the questions which are given at the end of the session. So in this lesson, what we are going to learn, let us see. We are going to discuss about electric current, amount of substance, light intensity, difference between the plane angle and solid angle, different types of clocks, accuracy in measurements, precision and approximation, rounding of numbers. First, we are going to discuss about electric current. Electricity plays an important role in our daily life. Even in our house also, we have many devices which work on electricity. That may be a television, computer or refrigerator or air conditioner, everything. So most of the devices nowadays, they are run by electricity. So the question is how the electricity is generated and how we can measure it. Now we will discuss. See this. The electric current is nothing but the continuous flow of electrons in an electric circuit. If you want to understand the electric current, first we have to understand the atomic structure of an atom. Any substance in the universe is made up of atoms. Atoms are the tiny particles. Even though the atom is a small, it itself having three tiny subparticles. They are protons, electrons, neutrons. Protons are positively charged, electrons are negatively charged, and neutrons do not have any charge. So the protons and neutrons are found in nucleus. The electrons which are having negative charge or resolves around the nucleus. Nucleus is nothing but the combination of protons and neutrons. The two are present at the center of an atom. So when we look at this picture, we can remember some other diagram also. That is nothing but solar system. In solar system, sun is the center point and the different planets or revolves around the sun. At the same way, here in atomic structure, nucleus contains the protons and neutrons, and the electrons, like a planet, these are also revolves around the nucleus. Being positive charged protons are present in nucleus, the electrons always attracted towards the protons. So the electrons which are present nearly or closely to the nucleus, they are very tightly bounded, and the electrons which are far away from the nucleus, they are loosely bounded. See this picture, how the electrons are resolved around the nucleus. In the nucleus of an atom, protons and neutrons are present, but electrons are resolved around the nucleus. This kind of loosely bounded electrons get some energy. They start moving from their original place. They start moving and go to another atom which is placed nearby. So in this way, the loosely bounded electron start moving from its original place and moving in a continuous flow. If it is a conductor, conductors are nothing but a metal wire having loosely bounded electron. That's why in conductors the electrons move freely from one atom to another. In this way, the electric current will generated. So now we are going to discuss about the definition of electric current. As we already discussed, electricity is nothing but the flow of electric charges. This electric charge is nothing but negatively charged electrons. Flow of electric charges in a particular direction is known as electric current. So the SI unit of electric current is ampere and it is denoted as capital A. 1 ampere is defined as 1 coulomb of charge moving in a conductor in 1 second. The formula of electric current is now I equal to Q by T. Here I indicates electric current. Q is nothing but the charge and T is in the form of time. This is the ammeter. Ammeter is a device or an instrument used to measure the electric current. So with the help of ammeter, we can measure the electric current. Next, we are going to discuss about amount of substance. Generally, if it is any substance, we can measure the value of their weight in the form of kilograms or grams or sometimes milligrams also. If it is a liquid form like a milk or fruit juice, we can use milliliters or liters. Can you imagine how many atoms present in 1 kilogram of rice or 1 kilogram of sugar? No, we can't measure because atoms are tiny particles which are not seen by our naked eye. Is there any other route to find or to measure the atoms? Yes, now we will discuss. This is a supermarket. In this, each and every atom have its weight on their back. Generally, we are taking the substances in the form of kgs, or sometimes if it is a fruits, we are taking in the form of dozens. If it is a liquid, we are taking in the form of milliliters. Now the question is, how many atoms present in 1 kilogram of rice, or how many molecules present in 200 ml of fruit juice? See these three circles. You just imagine the first circle represented 1 kilogram of rice, and the second one is 1 dozen of bananas, and the third one is 200 ml of fruit juice. These dots are we can able to measure because they are very small. You just imagine how many atoms present in 1 grain of rice atom and how many molecules present in 1 drop of fruit juice. So our answer is probably no, because we cannot see the atoms. But to count the amount of substance, there is an indirect method is present. That method is nothing but the mole concept. With the help of mole concept, we can measure the amount of substance. The mole concept was discovered by a scientist Amido Avogadro. Amido Avogadro discovered the mole concept, which is used to measure the amount of substance. The mole concept was discovered by Amido Avogadro. According to him, 1 mole is equal to 6.023 into 10 to the power of 23 atoms or particles. So 1 mole, the value of 1 mole is equal to 6.023 into 10 to the power of 23 particles. This number 6.023 into 10 to the power of 23 is called Avogadro number or Avogadro constant. So the Avogadro number is 6.023 into 10 to the power of 23. This is also called as Avogadro constant. With the help of mole concept, we can measure that amount of substance. For example, if you want to know how many atoms present in 1 mole of hydrogen, it is simply 6.023 into 10 to the power of 23 number of atoms. At the same way, in 1 mole of oxygen, we can find 6.023 into 10 to the power of 23 number of atoms. In 1 mole of carbon, we can find 6.023 into 10 to the power of 23 number of atoms. That means in 1 kg is equal to 1000 grams. Like that, 1 mole is equal to 6.023 into 10 to the power of 23 particles. With the help of mole concept, we can measure the number of atoms or ions or water molecules. Now we are going to discuss about the definition of amount of substance. Amount of substance is a measure of the number of entities present in a substance. The entity may be an atom, molecule, ion, electron, or proton. The SI unit of amount of substance is mole and is denoted as MOL. Can we see anything without light? No, because if there is no light, we cannot see anything. Because if there is no light, there is no reflection. If there is no reflection, we cannot see anything with our eyes. So the light which fallen on any object, it will reflect to our eyes. Then only we can see the things. That means if there is no light, there is no possibility to see anything around us. Can we measure the light? Yes, it is also a physical quantity. We can measure the light. Have you seen this situation anywhere? Yes, in cricket. Before playing the cricket, the umpire measures something with an instrument. Can you imagine what is that something he is measuring? That is nothing but he is measuring light intensity. Sometimes you are studied in a dim light or not sufficient light. At that time, you are feeling some irritation in your eyes. You are feeling headache also sometimes. That means if there is no sufficient light, it gives some inconvenience to reading. At the same way, before playing also, the light intensity is very important. While like a reading, for playing also, if there is no sufficient light, the playing is not a proper way. That's why the umpire, before starting the cricket, he is measuring the light whether it is a sufficient or not. The instrument which is present in his hand is nothing but photometer. Photometer is used to measure that light intensity. Now we discussed about what is luminous intensity or light intensity. Light is a physical quantity. That means we can measure that light intensity. Light intensity is measured with candela. Light intensity is also called as illuminating power. Luminous intensity is the intensity of a light source that can be estimated by human eye. That means the light which we can see with our naked eye. That is nothing but luminous intensity or illuminating power. Luminous intensity is denoted by the letter I. Luminous intensity of a given source is always constant. The measure of the power of the emitted light by a light source in a particular direction per unit solid angle is called luminous intensity. The SI unit of luminous intensity is candela and is denoted as CD. So luminous intensity is nothing but the power of light. Luminous intensity is nothing but the intensity of a light source that which we can measure with our human eye. Photometer, already we discussed about this. This is an instrument or device with which we can measure the luminous intensity. This is a photometer. Plane angle, it is the angle between the intersection of two planes. The SI unit of plane angle is radian and it is denoted as RAD. Solid angle, it is the angle formed by three or more planes intersecting at a common point. The SI unit of solid angle is steradian and it is denoted as SR. Plane angle and solid angle both are derived quantities. To measure this plane angle and solid angle, we need some luminous intensity. What are the difference between plane angle and solid angle? Plane angle, it is the angle formed between the intersection of two lines or planes. Solid angle, the angle between the intersection of three or more planes at a common point. Plane angle is a two-dimensional one. Solid angle is a three-dimensional one. The unit of plane angle is radian and the unit of solid angle is steradian. Clocks. We are familiar with different kinds of clocks. In our daily life, clocks play an important role in our daily life because daily we are measuring the time for different kinds of our activities. At what time we have to go to the school, at what time we have to write the exam, and how much time we have given to write the exam, like that. So these are some clocks which we are familiar. The first one is ancient clock. It is in a somewhat oldest clock, but still we can see this kind of clocks in some way. And quartz clock. This is normal classic clock which are present in our houses. And digital clocks. Whenever you are going to any railway station or bus station, there displays the time with the digits. And these three clocks are more familiar to us. And the last one is atomic clock. This is not familiar to us. Let us discuss about the clocks. Clocks, these are the instrument or device which is used to measure the time in our daily lives. Types of clocks. Based on the display and based on the working mechanism, clocks are of two types. The first one, based on display, analog clocks and digital clocks. Based on working mechanism, quartz clocks and atomic clocks. Now we will discuss one by one. Analog clocks. Its hand like a classic clock. It has three hands to show the time. This is a common clock which is found in our houses. The hours hand shows the hours. This is the short form. And minutes hand, it shows the minutes. When compared to hours hand, it is somewhat longer. Third one is seconds hand. Seconds hand is very thin and moves very fast. Analog clocks can be driven either mechanically or electronically. That means in sometimes in wall clocks we are putting batteries, or sometimes we can use the current wire and we can put in a plug. So analog clocks can be driven either mechanically or electronically. Digital clocks. A digital clock plays the time directly. If it is analog clock, we have to analyze based on the hands of the clock what is the time would be. But in digital clock, we can directly see the time. It shows in the time in the form of numericals or other symbols. Sometimes it having 12 hours display or sometimes 24 hours display. In railway stations or airports or sometimes bus stands, we can see this 24 hours display digital clocks. In digital clocks, they are showing date, day, month, year and sometimes temperature also. Digital clocks are often called as electronic clocks. Quartz clock. These are activated by electronic oscillations which are controlled by quartz crystal. The frequency of vibrating crystal is very precise. So the quartz clock is more accurate than mechanical clocks. Mechanical clocks are nothing but some analog clocks. So when compared to that analog clocks, these quartz clocks are more accurate. Then we can see that correct time by using the quartz clocks. Now we are going to discuss about atomic clocks which are not familiar to us. These clocks are more accurate when compared to any other clocks. These clocks are make use of periodic vibrations occurring within the atom. These are more accurate than any other clocks. The first atomic clock was developed in 1949 at the US National Bureau of Standards, but it was less accurate than the quartz clock. The first accurate atomic clock was built by Louis Essan and Jacques Penny in 1955 at the National Physics Laboratory in the United Kingdom. Uses of atomic clocks. Atomic clocks are more accurate than any other clocks. That's why they are used in global positioning system, global navigation satellite system and international time distribution services, because atomic clocks are more accurate than any other clocks. Now we are going to discuss about accuracy and precision. Both help us to understand the measurement. So measurement is nothing but comparing an unknown physical quantity by using a by using a known quantity. So what is accuracy and precision? Now we'll discuss about. See this first picture. Accuracy is nothing but how close a measurement or attempt is to the actual or target value. In this first picture, you can find three cross marks. That three cross marks are near to the actual site but not the exact. So this condition is said to be accurate. So this is the how close the measurement. Now let us take the another example. This is a 20 kilograms of dumbbell, and whenever you measure this you will get 18.95, 21.22 kg and 19.81 kilograms. That means you didn't get the same value in three times, but they are very near to the actual value. This kind of measurement is called accuracy. We are going to discuss about precision. How consist our results are regardless of proximity to actual or target. That means how many times you measure anything, you are getting the same results. That is said to be precision. Now let us take the first diagram. In this diagram, you can find the three cross marks in a same place. That means that is a not near to the exact, but three times you shot the same place. So this kind of situation is called precise or precision. And in 20 kgs of dumbbell, if you measure, you will get 23.11 kg, 23.09 kg, 23.12 kg. That means more or less in three times while you are measuring, you are getting nearly 23 kgs. So this is not the exact value, but whenever you are comparing or whenever you are measuring the measurement, you are getting the repeated same measurements. That repeated measurement is called precision. Now we'll compare that both accuracy and precision. Accuracy is measuring near true value. Precision is getting a consistent results. Now let us see this four examples. In first picture, the three times the shots are in same place and nearly to the true value. This is nothing but 100% accurate and precise. Whatever the measuring instrument, it should be accurate and precise. Otherwise, the measurements will mislead to us, and sometimes it will fatal to us. And we'll compare the second diagram. In this, we find three cross marks which are in a different places. They are accurate but not precise. Accurate means nearly come to the true value, but they are in a different places. And now we will compare with third diagram. In this third diagram, the three shots are at the same place but not near to the true value. This is precision but not accurate. Now we can compare the fourth diagram. In this, you can find the X mark in outer circle and one more X mark in near to the center. That means it shows not accurate and not precise. While measuring any instrument, we have to take the measurement in accurate and precise manner. That means the measuring instrument should be accurate and precise. Definition of accuracy. Accuracy is the closeness of a measured value to actual value or true value. Precision. Precision is the closeness of two or measurements to each other. Approximation. Approximation is the process of finding a number which is acceptably close to exact value of the measurement of a physical quantity. For example, normal human body temperature is 36.9 degrees centigrade or Celsius. So it have some decimal, so not convenience to us. So we can make it as a approximate value like 37 degrees Celsius. So approximation is nothing but finding a number which is acceptably close to the exact value. Now we are going to discuss about rounding of numbers. In lower classes, you have studied about this, and especially in maths. Can you tell me what is the rounding number of 995? You can easily tell that is a 1000. And what is the rounding number of 99? And you can easily tell it is 100. And sometimes whenever you are inviting your friends to your birthday, your mother prepared dinner for 10 members. Even though your friends came 8 members, your mother prepared for 10 members. That is nothing but rounding of the numbers. Now we are going to discuss about what is the rules and what is the definition of rounding of numbers. Rounding of numbers. What is the need of rounding of numbers and why we have to know about the rounding of numbers? Nowadays we are using calculators to do some calculations. Calculators are widely used in day-to-day life to do the calculations. The results given by a calculator has too many digits. Hence, the results containing more digits should be rounded off. The technique of rounding off is used in many areas in physics. Let us see what are the rules of rounding off. The process of dropping the last digit and retaining or increasing the second last digit by 1 unit is called rounding off data. This is the definition. The process of dropping the last digit and retaining or increasing the second last digit by 1 unit is called rounding off data. Rules of rounding off. There are 3 rules to round off the numbers. First one, decide which is the last digit to keep. For example, pi value is 22/7. If you convert this into decimal, we will get 3.142 something else. So after decimal, now we can have 3 numbers. So it is not convenient to calculate. That's why we have to decide first how many digits we want to keep. So we can take the last digit as 3.14. This is the first rule. After digit, we can use the 2 digits. And the rule number 2, leave it the same if the next digit is less than 5. That means if any number, for example, in above example 3.14, we are using 2 digits after the decimal. If the last number is below the 5 or less than the 5, we keep it as it is. That means 3.14. And the third rule, increase it by 1 if the next digit is 5 or greater than 5. So that means if the last digit is 5 or greater than 5, we can take it as a complete 1. For example, 6.95. So the last digit is 5. That's why we can take it as 7. 6.95, we can take it as a round off as 7. These are the rules which are followed to round off the numbers. I am repeating this again. There are 3 rules to rounding off the numbers. First one, decide which is the last digit to keep. That means after the digit, how many digits we want, first we have to decide. If the last number or last digit is below the 5, we just keep it as it is. If it is more than 5 or 5, we just add 1 to make it a round. Now we are going to discuss about the mind map of measurement lesson. In this measurement lesson, we discussed about SI units. SI units of base quantities. They are temperature, electric current, luminous intensity, amount of substances. And derived quantities. They are plane angle and solid angle. Plane angle unit is, that means plane angle SI unit is radian and the solid angle SI unit is steradian. Temperature SI unit is Kelvin. Electric current SI unit is ampere. Luminous intensity SI unit is candela. Amount of substance SI unit is mole. And we discussed about different types of clocks. Clocks are the devices with which we are measuring the time. Based on the display, clocks are of 2 types, and based on the mechanism, clocks are of 2 types. Analog clock and digital clock, both are different kinds of clocks based on the display. Quartz clock and atomic clocks are different types of clocks based on the mechanism. In this, atomic clocks are more accurate clocks than any other kind of clocks. And accuracy in measurements. In accuracy, we discussed about accuracy, precision, approximation, and rounding off. Exercise. Define electric current and write its SI unit. How can we measure the luminous intensity? What is amount of substance and write its SI unit? Write the value of Avogadro's number. What are the types of clocks? Write the uses of atomic clocks. What are the rules of rounding off? What are the difference between plane angle and solid angle? Define accuracy and precision. And what is approximation? Suggestion. Students, if you have any doubts regarding this session, please note that particular topic in your notebook. After the school reopens, that doubts will be clarified. Thank you.